Okay, so today's topic of discussion will be more of practical in nature. Nothing new. I'm just, recollecting the concepts which you may have already learned in the previous classes. Now, first of all, you need to understand the concept of block. Block is a statement or a group of statement enclosed within opening and closing brace. So, enclosed with an opening and closing brace, you may have a single statement or a multiple statements out there. So, in that case, we call this entire enclosed area a block. And this particular statement is called a compound statement because it combines multiple statements into a single unit, hence the name compound statement. Now, this block maybe a function block, that is, you had been writing static void main or public static void main, whatever you had been writing, that's a block. Even for a if statement, if you have multiple statement, you must have used braces, or even if you have used, for a single statement, there even you have used a block. For a else, you may have a block. For or a while or a do while loop, anywhere you can have a block. Now, what is important out here is if you have a variable which is declared inside a block, its scope is limited inside that particular block only. You see, you have to understand the scope of a variable. The scope of a variable means the area within which that particular variable is accessible. So, in this case, the scope of a variable will be only within the block where you have declared. For example, if I have a statement over here, int a, say for example int a equal to 10. Now do not expect you to access that variable. You cannot write something like this, a equal to a plus 5 out here, expecting the value of a to be 15 out here, getting updated or incremented by 5. No, nothing of that sort, because a scope of this variable a is limited within this block only. It has no existence outside it. So please be careful when you are using or declaring variable inside a block. Next. Now remember, this block may be for a if statement or for a for statement. Remember either of them. Now I'll go into slight more detail when it comes to for loop. I have seen few mistakes students are doing. So I would like to discuss that. Suppose, say for example, you have written something like this: for. Some of you have the habit of declaring the variable out here. That's completely valid. I have no issues with that. I plus plus. And here, whatever operation you wanted to do with I, you are doing it. Now, please remember that the variable I, its scope is limited, although it is declared outside this particular block. But since this block is of the for loop, the int I, the variable I, its scope is limited only within this block. Okay, the variable I is limited only within this block. It has no existence outside it. So you cannot write, system.out.println out.println, you cannot display the value of I, or you cannot access. In other words, you cannot access the variable I because its scope is limited only within this block. So please be careful when you are declaring variables inside the for, within this parenthesis of the for. So during initialization, if you declare, please remember this particular variable, its scope is limited only within this for loop. If you once again need to use the variable I, you need to once again redeclare it, either in the same way or in the usual method. But please remember, the scope of a variable is only limited within the block where it is declared. If you declare it inside the block, it has no existence outside it. For a for statement, if you declare a variable in the initialization part, its scope is limited only within this braces, not outside it. So please keep that in mind. Now, what we are going to do is, we are going to discuss the first question of the assignment, the last assignment which I had given. The first question is input 10 numbers and find the average of even numbers only. Now some of you still have the hangover of arrays of C++. You have learned arrays prior to this in C++. Now in Java you are suddenly having this question of finding the average of even numbers. You are still having the hangover. You still use two different loops. One particular loop to input all the numbers and one particular loop to find the sum of the even numbers. Nothing of that sort happens. Please keep this in mind that we are not using arrays. So you need to do every kind of operation in the same loop. Those who understand that, please understand, those who are using this concept of array, no, we are not holding data, we don't have multiple spaces. We just have one space inside which we are, replacing the previous value with a new value. And those who are doing it for the first time, Look at the solution to this problem. It's very simple, pretty simple. So we'll begin with the scanner object. New scanner system.in, and here what we are going to do is I'm going to declare the variables, and I can print a message, enter 10 numbers. So system.out.println, enter 10 numbers. After this we can run a loop from 1 till less than equal to 10, I plus plus. Here I have declared the variable I. Now what we are going to do is we are going to input a number. Try to understand what I am trying to tell, those who are doing it for the first time. Here you know that when I execute a loop from 1 to 10, it's going to iterate 10 times. And inside this, whatever I am going to write is going to iterate 10 times. It's going to happen or occur 10 times. So if I input inside this particular for loop block, since the loop is going to execute 10 times, the input is also going to happen 10 times. However, 10 times we are going to use the same variable to access, to input the numbers. Now the problem is, when you input the first number, it gets stored in A, no doubt regarding it. When the loop executes for the second time, suppose the loop closes out here. Suppose the loop executes for the second time, when you input, again it gets entered inside the variable A. So what happens to the previous value? The previous value, which was already there in A for the first iteration, gets replaced with a new value. So that's completely lost. So that is why you have to keep this in mind. All inputs should, or all operations that you are going to do, should be happening out here only, not outside this. So now, getting back to the question was find the average of even numbers only. So when I need to find the average of even numbers, what do? We'll check whether the number which you have entered is even or not. If a modulus 2 equal to 0, then what are we going to do? We are going to find the sum. Remember how to find the sum? We'll take a variable where s is 0. So we are going to write s equal to s plus a. Along with that, I'm going to use a counter to count how many even numbers are there. And after doing that, I can print the average. So I can print the average out there. System.out.println. I can print the average here. Remember, don't forget the typecasting float. Otherwise, you may not get the answer in decimal point, although there is a possibility of getting the answer, the average, in point. So please keep that in mind. Whenever we divide, we will not forget the typecasting. So that's it. This is what we do. Float typecasting S divided by C. Or you can store this into a float type variable and ultimately print that variable. So it's that simple as this particular program. You can see it's quite simple, isn't it? Now we'll go for the second question. Now look at the second question. Input 10 numbers and display the largest and smallest. Now this is an interesting question. Though most of you have already done this before, still I am going to discuss this because there were a lot of corrections which I had to do with the assignment which I had given. So you need to understand this concept first. Now see what actually happens. Suppose you have a block. Remember the block? A group of statements with an opening and closing brace. Remember, if you have declared a variable, suppose I have declared a variable out here, a group of statements before it. So int a, I have declared a variable. I have used that variable out here. That's perfectly valid. No problem with that. And I'm also accessing it outside. In that case, you need to initialize those variables. Please remember, if you use a variable inside a block and use it outside that block also, you need to initialize such variables. For example, I'll give you an example. Let me give you a more practical example. Suppose I have a variable, say b, where b is initially 10 and a is not initialized. Now you see what happens. And I'm going to write this statement: if b is greater than 5, then a equal to 20. I write this statement. And okay, I have less amount of space. And here I'm going to, outside the if block, I'm going to display the value of a. Now what do you think is the output. Now here what actually happens is B is 10 and obviously 10 is greater than 5, so A will be initialized with 20. When you come out of this is block, what is the first statement it comes across? System.out.println A. So definitely it's going to print 20. However, nothing of this sort happens. What will happen is when you compile this particular program, it's going to show you an error. Why? You have to understand this. This is not C++. In C++, you'll definitely get the answer 20, but in Java, it will not allow you to run the program. Forget about what is the answer. It will not execute it. Right? So, why? What is the reason behind this? So, when you are compiling a program, please understand, Java thinks that, it never checks for the condition, remember. When you are compiling, remember, it never checks the condition. It only checks whether it is syntactically correctly written or not, whether it is grammatically written correct or not. Now here, this is grammatically written perfectly alright. Now it thinks that suppose this condition do not get satisfied. It never thinks that actually the condition is getting satisfied because it is not executing. It thinks, suppose this condition is not satisfied, it will never enter the loop. And now if I display the value of A, what is the value of A? It's going to display. So it thinks it this way because Java do not have the concept of garbage value like in C++. Some of you have already learned in C++ that if a variable is not initialized, it already has a value which is taken over or given by C++. And since it is an unwanted value, we call it a garbage value. So any unwanted number a variable is going to have. In Java, we do not have anything of that sort. So what happens is, here, if the value of B is greater than 5, A will be 20, it's definitely going to print A. It's going to print 20. However, when you are compiling means what? It's checking whether it is syntactically correct or not. And in Java, it's going to convert it to a bytecode language. So now, it thinks it this way. Suppose this condition is not true and it never enters this if block. If I am going to print A, what is it going to print? Because A doesn't have any initial value. It doesn't have any garbage value like in C++. So it will show you an error. In such situation, the error will be A might not be initialized, might have not been initialized. So such a message will be displayed. So please keep that in mind. If a variable is used in a block, it may be a if block, it may be a for block. And also used outside it, it should be initialized. You can initialize it with anything, it doesn't matter. But you need to initialize it so that you make the computer think that if it do not enter these blocks, still if you print it, it's going to print that initial value. Now we'll go for this particular question, that is input 10 numbers and display the largest and smallest number. We'll begin with a simple thing. Some of you already know this, but some of you are doing it for the first time. So I'm going to discuss how to find the largest among a list of numbers, a group of numbers. Let's begin this way. Suppose I have these numbers 5, 12, 25, say 15, 19, 35 and 11. Of course, which is the largest number out here? Of course 35, no doubt regarding it. It is obviously 35, and how did you do it? You have actually basically compared it with all the numbers. This is how humans work. So same thing we can make the computer do it also. But remember, computer, the program, what you are learning currently will allow you to access only one value at a time. So you cannot see all the numbers together that you can decipher which is the largest, like we humans are doing right now. What we are going to do is, we are going to make the computer work in such a way that it ultimately finds the largest number and stores it into a variable, say L. Now, what is the technique involved? So L is initially what? What we are going to do is, among this list of numbers, the first number, now this may be any set of number, please remember, the user can input any set of number. The first number which you are going to input is going to get stored inside the variable L, so L will be 5. Next, the subsequent numbers, what we are going to do is, remember, every time you are getting only one number at a time. So for each subsequent number which we are going to get, we are going to check whether its value is greater than L or not. If it is greater than L, then we are going to assign it to L. So here we have 12. 12 is greater than L, then L is assigned this value, so L is 12. Next comes 25. 25 is also greater than L, so give it 12 or assign it 12, so L is 25. Next comes 15, is it greater than L? No. Next comes 19, is it greater than L? No. Next comes 35, is it greater than L? Yes. So L will be assigned with a new value 35. Next comes 11, is it greater? No. So ultimately L contains 35, which happens to be the largest number. So once again, recollecting the method, very simple, isn't it? Recollecting the method, what did we learn? We learned that the first number which I am going to input, I am going to store it into the variable L. And subsequent numbers which I get, I am going to check whether it is greater than L or not. If it is greater than L, then I am going to store it into the variable L. So this is what I am going to do. Let's start with this. I assume you have already written the scanner object, so I'll begin with the integer part, the declaration part. I can print a message, enter 10 numbers, and here once again we'll start with the for loop. And here we input. Remember, this input will happen 10 times because the loop is going to iterate 10 times. Now, what we are going to do is, we are going to store the first number inside a variable, say L. So L will contain the first number which is entered by the user. So what is the technique involved? There are various ways of doing it. Using flag variables, using this variable I itself. What I'm going to do is, I'm going to use one particular method which can be applied in any particular technique. So here, I'll take a variable C which is initialized with 0. Simple as that, C over here. What I'm going to do is, I'm going to put a counter. So I'm going to increase the value of C by 1 every time the loop iterates. So every time the loop iterates, C is increasing by 1. And since the value of C is 0, when you execute the loop for the first time, what is the value of C? Obviously it's 1. So when you are executing the loop for the first time, the value of C is 1. And it will be 1 only when the loop executes for the first time. And when the loop executes for the first time, what does it mean? Whatever number you have stored in A, isn't that the first number? So when the loop executes for the first time, the number which is entered by the user inside the variable A, isn't that the first number? Because every number will be stored in variable A only, it will replace the previous value. But if the loop executes for the first time, whatever number you have entered will get stored inside variable A. And this particular number I am supposed to store in L. So this is supposed to happen only for the first time, when the loop iterates for the first time. That is, I want to store the value 5. So here what we do is, we put a counter and we put a check. If C is 1, so when will C be 1? C will be 1 only for the first time. Because the subsequent execution of the loop will carry on increasing the value of C. So C will be 2 for the second time, C will be 3 for the third time. So like that you can carry on. What is important is, C will be 1 only for the first time. And for the first time, whatever is entered inside the variable A should be stored in variable L. So I assign the value of A to L. So this if is only going to work for the first time, because only for the first time the value of C is 1. Next time onwards, so else if, next time what did I tell you? If the number which is entered by the user happens to be greater than L, then I'm going to assign it to it. So the next number is entered in which variable? Obviously that A, the same variable. So that same variable, if it happens to be greater than L, then replace its value, so L equal to A. So this process will continue. And ultimately we'll get the largest number in L. After that you can always, you can just simply print it over here, print the value of L. Simple as that. I believe you understood how to do this. Now, what you are going to do? Now, listen to this statement. Suppose, and here I am going to, let me write it clearly, otherwise some of you will still get confused. Let me display the value of L, system.out.println. Out.print. Suppose I display the value of L. This is what I am doing over here. At the end of this for loop. Because by the time the loop ends, the largest number already got stored in variable L, so that is what I am printing over here. Now you see, when you compile this particular program, the first thing, what will happen is, Java thinks it this way. Suppose this particular loop do not get executed. When will it not get executed? Suppose this condition is not valid, because it is unable to see. It is only checking whether syntax is correct or not. It is not seeing whether this condition is true or not. So here, suppose it thinks if this condition is not true, so this loop will never get executed. If it do not get executed, and if I display the value of L, what will it display? So because since there is no concept of garbage value, it's not going to print any garbage value. That is why it will give you an error message, L might not have been initialized. That is why in Java, we need to initialize the value of L with 0. Remember that. C is a counter, obviously C will be need to be initialized, but when it comes to finding the largest number, that is why in a lot of your solution which you have passed, I have done this correction. This is what happens, because if you use a variable inside a block and also use it outside it, it should be initialized. Hence this. Some of the people have the habit of initializing every possible variable because they don't have this concept. You see, I do not require. Why? Because the variable I is being used inside this loop block, but I don't use it outside this block. Similarly, A need not be initialized because I'm using it inside this for loop block, but I'm not using it outside it. Whereas L, I require it. C is a counter, we require it. But when it comes to L, I require it because I'm using L over here inside this block as well as outside it. Therefore, we require this also. So I believe you understood, isn't it? Very interesting, the concept. Now we'll go for that particular question. Input 10 numbers, display the largest and smallest. And strangely enough, let me tell this. Some of you forgot which is the greater symbol, which is the smaller symbol. Smaller than symbol. That's quite sad, disheartening. Okay, let me take another variable, S. And remember, even S needs to be printed. Where S will be the smallest number, even this needs to be initialized with 0. So what we are going to do is, if C is 1, L equal to A, along with that the first number, I am going to store it in S also. Remember, this is a multiple assignment statement. You could have also written it this way. Remember, if C is equal to 1, this would have been written in two statements, S equal to A and L equal to A. Now, this is written in a single statement, we call it multiple assignment. So this A will be assigned to L also, S also. Now, if A is greater than L, L equal to A. Similarly, if remember, we can simply remove this. If A is less than S, S equal to A. You can write this way. So if A is greater than L, L equal to A. If A is less than S, S equal to A. So this process can continue. Of course, we can write else if also, no issues with that. Else if we can also write that. A is less than S, S equal to A. Ultimately, you can display the value of L. Along with that, you can display the value of S, the smallest number. Of course, with the proper message. So this is how we find the largest and smallest among 10 numbers. Now we are going to go for the next question. That is, input 10 numbers and display the largest even number if any. Basically, it's a modification of this particular question. Largest even number. So I just made it a bit short instead of largest and smallest. So what I'm going to do is, I'm going to put a semicolon out here. And now, the only thing which I'm going to do is, now, what does it mean by if any? Finding the largest even number if any. You see, among these 10 numbers, it is not necessary that the user is going to input all even numbers. There may not be a single even number entered by the user. In that case, how is the computer going to print the largest even number? In that case, it should print there is no even number. So, since there is no even number, there is no question of having the largest even number. So, that should be mentioned. So, if C is 1, what am I going to do? I am going to store L equal to A, that is the usual stuff which we had learned, while finding the largest number. Else if A greater than L, L equal to A. That part is same. What we are going to do is, we are going to modify this particular program to find the largest even number. So here, the only thing what we are going to do is, we are going to check, after entering a number, we are going to check whether the number is even or not. Simple. If A modulus 2 is equal to 0, only then I am going to find the largest. This particular method is the technique for finding the largest, and I am going to find the largest, this particular block, only when the number is even. So only when it is even, it's going to check or find the largest number. And after the end of the loop, here we are going to put a check. Say for example, after the end of the loop, I'm going to write it out here because of the space crunch. Now, you see, when I get an even number, C will always increase. Now, if C continues remaining as 0, even outside the loop, what does it mean? There is no even number at all. So here we are going to put a check. If C is greater than 0, then we are going to print the largest even number. System.out.print. The largest even number is L, you can print that. Otherwise, you can print no even numbers. system.out.print println no even numbers. You can print this message. See, simple as that. I just simply modified this to adapt to the requirement of that particular question. Got it? I believe. Okay, now we'll go for the next question. Okay, now we are going to go for the next question. And what does the next question tell us? Input an integer and find the sum of its digits. So we are going to input an integer and find the sum of its digits. Some of you use a while loop. Okay, no problem with that. But you can also do that using a for loop. And it's always advantageous to use a for loop. So here what we are going to do is, we are going to do it this way. Expecting the scanner object to be written previous to this. So how do we do that? First of all, we'll print a message system.out.println, enter a number, the usual message, and we enter an integer. And now what I'm going to do is, I'm going to run a for loop. From A, that's the initialization part, I greater than 0, I equal to I by 10. So those who are doing it for the first time, this is how we do. And then we extract a digit, so t is equal to I modulus 10. And then what we do, we find the sum of that particular digit, sum s equal to s plus d. That's it, it's over. That's how we find the sum of its digits. Now I'll show you how it works. You don't need to worry. I'm going to display the value of s after this. So those who are doing it for the first time, see how this works. Suppose, say for example, I enter the value of a to be as 456. Suppose the value of a is 456. What does the first statement become over here? Look at the initialization part of the for loop. I equal to a. So the value of I will be obviously 456. And what is written over here? I is greater than 0. Is the value of I greater than 0? Yes. I is 456. It's greater than 0. So it enters the loop. After entering the loop, what is the first statement it comes across? D equal to I modulus 10. And when you divide number by 10, the remainder is always the last digit. So naturally, D will be 6. So S equal to S plus D. So S will be, S was initially 0, 0 plus D, 0 plus 6 is how much? 6, obviously. So next, again, it comes to the updation part, and in the updation part, what is written? I equal to I by 10. So I equal to 456. So now what is the new value of I? I will be 45. And now even 45 is greater than 10. So D equal to I modulus 10. So what is D? D will be 45 modulus 10, the last digit, 5. S equal to S plus D. S was already 6. Now I add 5 to it, we get 11. Simple. Next, again, the loop comes over here. Again, in the updation part, I equal to I by 10. So what is the new value of I? I will be 4. Now even 4 is greater than 0. So D equal to I modulus 10. So 4 modulus 10. Even if it is a single digit, you still get the last digit. So D equal to 4. You see how it is divided. Some of you have a confusion how this happens. 4 when divided by 10, 10 zeros are 0. Remainder is still 4. That is why we get that. Remember. S equal to S plus D. So S was 11 and I add D to it, that is 15. So the new value of S is 15. Now again it iterates. I equal to I by 10. The value of I is now 0 because 4 divided by 10, integer division, remember there is no point. 0, and since 0 is no longer greater than 0, it comes out of the loop and displays the value of S, and in this case the value of S is 15, so it gives the output as 15. I believe all of you understood this. Now what is the next question? Input an integer and find the frequency of the largest digit. This is perhaps a similar question. Here what we are supposed to do is, we are supposed to input an integer and find the frequency of the largest digit. That is, how many times the largest digit is occurring in that particular number. For example, suppose 9 is the largest digit over here. So what is the frequency of the largest digit? Obviously 3, because 9 is occurring 3 times. So you are supposed to print 3. That is the frequency of the largest digit. So how do we do this? We are going to apply the same technique, that is finding the largest. Remember what we have done with the finding the largest among 10 numbers? We are going to do exactly that. Look at the process involved. So see over here how this is working. Suppose I input an integer and The usual method, I put a counter p equal to 0. So say d equal to I modulus 10 because I need to extract a digit and I need to find the largest digit, hence extracting the digit. And I put a counter p plus plus. Remember out there I put a counter c plus plus. Okay, let me put it c. Some of you will still have a confusion. C equal to 0, so c plus plus. Now if c is 1, what am I going to do? I'm going to store the first digit which I extract. That is the last digit. In this case, I'm going to store it in L. So L equal to D. Next, else if the value of D, if it is greater than L, then L equal to D. This is what we do. So we got the largest digit. And remember, don't forget the initialization of L because I need to reuse the value of L. Now after this, what I do is, the next part, here I found the largest digit. Now some of you were finding the frequency in the same for loop. Please understand something. Until and unless you don't check it with all the digits, how can you tell that you got the largest digit in L? So only when you come out of the loop, what does it mean? That means you have checked with each and every digit. But by then, you have already come out of the loop. So how on earth are you going to check which digit is matching with the largest digit? So the technique involved is, first at the end of this loop, what is the value of L? L will be obviously 9. And now what we are going to do is, once again we are going to extract each digit one at a time. Remember, we are going to extract each digit from the end, and after extraction we are going to check whether it is matching with L or not. If it is matching, then we are going to put a counter. You cannot do it in the same loop because until and unless the loop do not end, you cannot tell L contains the largest digit because you have not exhausted with all the digits in that particular integer. That is why we cannot do it in the same loop. So we'll do it in a separate loop. So here again we'll start extracting each digit. I greater than 0, I equal to I by 10. And here extract a digit, d equal to I modulus 10. And if this digit happens to match with L, then put a counter, p plus plus. So if the extracted digit is matching with the largest digit, I am counting how many times it is matching. So now I am going to display the frequency. So system.out. So I can declare the variable p equal to 0, put a semicolon, dot print. You can print a message, frequency of the largest digit, and ultimately display the value of p. I believe you understood this. The first part is extracting or finding the largest digit, and in the second part of the loop, it's checking how many times the largest digit is present in the same number, that is inside the variable a. I believe all of you got this. Now we'll go for the next question. And what do we have in the next question? We have input an integer and check whether the sum of its digits is a prime number or not. Now, this is very simple. So first what we are going to do is we are going to find the sum of its digits. After finding the sum of its digits, most of you have done this correctly, we are going to check whether that sum is a prime number or not. So the first part is the usual, finding the sum of the digits. So here all the questions are related, so I don't need to rub the entire thing if you have observed. S equal to 0, so S equal to S plus D. So what am I doing? I am finding the sum of the digits and inside the variable S. Now what I am going to do is I am going to check whether this S is a prime number or not. So for checking prime number, remember what a prime number is. Prime number is such a number which has two factors. So first of all I need to count how many factors are there. So here factors lie anywhere between 1 till that number. So here till that number means I am supposed to check whether S, where S is the sum of the digits, is a prime number or not. So starting from 1 till S. So if the sum is 6, I am going to run a loop from 1 to 6 and check how many times, how many numbers are there. 6 is completely divisible by. So here in this case 1, 2, 3 and 6. So there are 4 numbers. So since there are 4 numbers by which 6 is divisible, that means 6 is not a prime number. Only if it has 2 numbers by which it is divisible, then only we can tell that it's a prime number. So that is what we are trying to do, and here we are going to check whether S is divisible by I or not. So when S divided by I, the remainder happens to be 0, that means it is divisible. In other words, I am checking whether I is a factor of S or not. In that case, I am going to put a counter. So C++. So I am counting how many factors are there. Whenever a number is divisible, we can tell that particular number is a factor. So S modulus I, that means I is a factor. And since it is a factor, I am increasing the value of C by 1. At the end of this, what I am going to do is I am going to check whether C is 2 or not. So if C is 2, I can display a message system.out.print. I can tell the sum of the digits is a prime number, otherwise else the sum of the digits is not a prime number. So this is what I am going to do. Simple. Yes? Okay. Now we'll go for the next question. That is, input an integer. And remember, you should be, taking screenshots, and later on, some of you who don't get it, you can take screenshots of the program, and then you can slowly write it in your copy later on. But now, concentrate on what I'm trying to tell. Look at the next question. Input an integer and remove the odd digits from it. Now, you have learned how to extract each digit from an integer. Now we'll do the reverse process. From the digit, we are going to learn how to make the number itself, how to bring back the number. So what we are going to do? Okay, so what we are going to do is, we are going to form a number back from the digits. Now let's try to understand a recollection of the basics which you have learned in mathematics prior to this. Say for example, you have this 4163. Now, what is it basically? Remember, we had learned in mathematics something called expansion. So this is 3 into 10 to the power 0. This is 6 into 10 to the power 1. This is 1 into 10 to the power 2. This is 4 into 10 to the power 3. So here we have 3 into 10 to the power 0 is 3. This is 60. This is 100. This is 4000. When you add this, we are going to get 4163. So each digit, we can use it to form back the number. Now for the corresponding code, what I am going to do? Here I am going to run a loop for I equal to A, where A is the entered number, I is greater than 0, and here we have I equal to I by 10. Now what I do is I extract a digit, I modulus 10. Now if, no question of if. Now what we are going to do is we are going to form this number. So here what we will do, we will write S equal to S plus, where S is the sum, this addition, D into, D is the extracted digit, into math.pow. This is the power function in Java. We write it math.pow, where M in math is capital. Math.pow 10 comma C plus plus, where C is initially 0. In declaration, you can simply write the value of C to be 0, and of course S is also 0. And that's it. Now look at this, what actually happens. So D is the extracted digit, so obviously it will be initially the last digit. So that extracted digit into math.pow 10 to the power C, where C is initially 0. So 10 to the power 0 is 1. So 3 into 1, it's going to multiply, and the value of C became 1. So next time when you extract the next digit, the second last digit, that will be multiplied with 10 to the power of 1. So 10 to the power of 1 is 10, and therefore you will get this, and the value of C will become 2. And after that, whatever digit you extract, that digit multiplied by 10 to the power of 2, and the value of C will be 3. So the next digit will be multiplied by 10 to the power of 3, or 1000. Like that it will carry on. And what is happening is, the variable S will get back the number, the original number. Now getting back to this question, what is mentioned over there. Input an integer and remove the odd digits. That means what I am asking you is, I am asking you to form back the number using only the even digits. Yes or no? So for example, suppose I have a number like this, 41632. What I want you to do is, I want you to remove which digits? Remove all the odd digits. That means using the even digits, you are supposed to form back the number. This is what you are supposed to do. 462, removing all the even digits. So you are supposed to form a number using only the even digits. That's it. That is what we are supposed to do over here. But however, I just missed out one thing. When you use the math.pow function, remember, do not forget to typecast here int. The reason behind this is, in Java, the math.pow function returns double value. The value, raising the second number to the power of first number, it is returned in the form of decimal point, double. It cannot be assigned to integer. That is why we need to typecast. So if I give mat.pow 3,2, instead of giving 9, it gives me 9.0, which is a double value. And remember, we cannot assign double to an integer. We need to typecast it. We had already discussed this. That is why I am not explicitly explaining you once again in this particular video. Now getting back to this, we are supposed to form back the number using only the even digits. So what we are going to do? We are simply going to write if d is even. If d is even, then form back the number s equal to s plus d into all that. If it is odd, we are going to do nothing. After the end of the loop, you can display the value of s and it's going to form a new number using only the even digits. It's that simple. I believe all of you got it? Okay, now we'll go for the next question. Now look at the next question. Input an integer and form a new number where the digits are in ascending order. Now look at this. This is a very interesting question. Input an integer and form a new number where the digits are in ascending order. Now, what we are going to do? Let's try to understand this question and then we are going to understand how we do it programmatically. Suppose we have this 441,937. What I am supposed to do is, I am supposed to form a new number using that formula. Remember, s equal to s plus. I taught you how to form back a new number from the digits. So hence this question, form a new number. Some of you were only printing it in ascending order. You did not create a new number. Though I have given a tick mark, thinking that you got the concept, but you were supposed to form back the new number. Now suppose you have this number. What I want you to do is form a new number with the digits in ascending order. That is 1, 3, 4, 7, 9. This is what I want you to do. That is, the digits are arranged in ascending order. Now how do we go about this? What we are going to do is, we are going to start a for loop from 9 to 0. The while from 9 to 0, I am going to start a for loop from 9 to 0. Why? Because 9 is the largest possible digit in a number, in an integer, and 0 is the smallest possible digit. So I am starting a loop from 9 to 0. Now, what I am going to do is, every time I get a number from here, of course, in the range from 9 to 0, I am going to check whether that particular digit is present in the number or not. That is in the original number, that is the number entered by the user or not. If it is there, we are going to use the number formation formula technique to get back the number. So let's start. What is the first number we get from this formula? 9. Now we are going to check whether 9 is there or not. Is 9 there? No. No. Yes, we got it. So if it is there, so what we are going to do? 9 into 10 to the power of 0. We are forming back the number. So we got 9 obviously. Next, what do we have? 8. From this loop. Is the digit 8 present over there? Of course, extracting each digit, we have to check it. No, 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 no. So 8 is not present. Next comes 7 from there. Now we are going to check. Yes, 7 is there. So 7 into 10 to the power of 1. We get 70 out here. Next comes 6. Now again 6 isn't there after extracting each digit. Next comes 5. Again 5 is not there. Next comes 4. Yes, 4 is there. So 4 into 10 to the power of 2. So we get 400. Remember. Next comes 3, and yes, 3 is also present. So 3 into 10 to the power of 3. So we get 3000. Next we get 2. Again 2 is not there. Next comes 1, and 1 is there. So 1 into 10 to the power of 4. So what do we get? We get 10,000. And after that 0 is there. Even though we could have missed that 0 also, no problem. Even if I give no problem with that, and even if 0 is there, it doesn't make any difference because 0 into anything is 0. So anyway, and if the 0 remains before it, the number will still remain the same. So here, what do we have? If we add it, what do we get? 1, 3, 4, 7, 9. Aren't the digits arranged in ascending order? This is what we are supposed to do. So how do we do it? Pretty simple, isn't it? Now you got the trick. So we'll start with the loop for I is equal to 9, I greater than equal to 0, I equal to I by 10. Now, we'll start extracting each digit from the number. So how do we do that? For I equal to, not I, j equal to a, j greater than 0, j equal to j by 10. Next, extracted digit d equal to j modulus 10. And if this extracted digit is matching with I, then S equal to S plus the number formation technique D into, remember the typecasting, int man dot power 10 comma C plus plus. That's it. After that, we can simply print it, system.out.print S. That's it. Simple. I believe all of you got this. Okay. Now we'll go for the next question. Yes, this is a very interesting question. Input 10 numbers and print the second largest number. Once again, some of you still had the hangover of arrays and tried to solve it using like an array. Array had an advantage that all the numbers get stored. It gets stored. So when you come out of the loop, the numbers are still there in the array. But here, since we do not have the concept of arrays, at least for time being, you are supposed to find the second largest number inside the same loop itself. Now we are going to understand first how to find the second largest number. We have already learned how to find the largest number. Now we are going to learn how to find the second largest number. Now suppose you have this group of numbers 14, 15, 25, 36, 11, 49. Suppose you have this group of numbers 15, 25, 35. Suppose we have this group of numbers. We'll take two variables, say L and SL, where L indicates the largest number, SL indicates the second largest number. Now what we are going to do is, we'll start with the first number and store it into the variable L, the usual method which we have learned. So the first number I'm going to store it in L, 14. SL is remaining untouched, remember, we are doing nothing about it. Now, whenever we get a number which is greater than L, that is subsequent numbers I'm talking about, if it is greater than L, then whatever was the previous value of L should be given back to SL and then L should be assigned with the new value. Now what happens over here? Next number we get is 15 and 15 happens to be greater than L. So what I'm going to do is, the value of L, I'm going to give it to SL. So this will be 14 and L will be getting the new value, that is 15. Next comes 25. And what do we find? Is 25 greater than L? Yes, 25 is greater than L. So the previous value of L should be given to SL. So this is 15 and L will be assigned with the new value, that is 25. Next comes 36. Now, is 36 greater than L? Yes. So what we are going to do, this 25, I'm going to store it in SL and this will be 36. Now what do we have? Next we have 11. Now 11 is not greater than 36 and neither is it greater than SL. So we'll go for the next value, that is 49. And 49 is greater than L. So what am I going to do is, I'm going to write over here 36 and this will be 49. Next comes 35 and 35 is not greater than L, neither is it greater than SL, so it will remain like that. And say for example we have one more number, say for example 44. 44 is not greater than L, however it is greater than SL, so SL should be this 44. So SL ultimately contains the second largest number. So this pretty simple technique we are going to apply. Now see what we are going to do. Suppose we run the for loop, assuming all the statements you have written previously. Less than equal to 10, I plus plus. Now we input a number, A equal to SC dot next int. We input a number. And what is the first thing we do for finding the largest number? So if I is equal to 1, I could have used a counter also. If I equal to 1, this is a very simple part of the program. So if I is 1, the same thing. That means the loop is iterating for the first time. And whatever is the value of A, I am going to give it to L. Next time onwards, if A, see the same technique which we found while finding the largest number, A is greater than L, then what we are going to do? The previous value of L should be given to the variable SL. So SL should be L and L should be getting the new value, L equal to A. So this should be the thing. Now, it is not necessary that A will be greater than L and only then SL will be having. Whatever is the value of A, after that I need to check whether it is greater than SL or not. Now before doing that, what we are going to do is, we are going to mark that SL already contains a value. So how do we do that? Whenever we assign a value to SL, let me take a variable f which is initialized with 1, a flag variable we call it. Technically, it's simply an indicator. So initially the value of, in the declaration part, remember, the value of f is initially 0. Now whenever we got a number which is greater than L, and since I am assigning a value to SL, I'm marking it. That is, I need to tell the program that SL already contains a value, so F will be 1. So when you come to the else block, here we are going to see if F is 0. So if F is 0, that means prior to this else block, SL never got a value. So if F is 1, that means it has a value, but prior to this, if F is 0, that means prior to this SL never got a value. In that case, whatever is inside A should be SL. And next time onwards, you should check if A is greater than SL equal to A. So this is what we are supposed to write, and followed by the end of the for loop. Now if you display it, it's going to display the second largest number inside the variable SL. I believe all of you got this. So what did we do? The first number we are storing in L. That's fine. Next, if any number is greater than L, then I am assigning the previous largest to SL and followed by the new number to be the largest. And along with that, I am marking whether I got a value inside SL or not. And if it is not greater than L, next what I need to do is I need to check whether it is greater than SL or not. Now the problem is SL may have a value because of this statement, or it may not have a value. So that is why we put a if statement. If F is 0, what does it mean? It means SL never had a value. So if F is 0, whatever is the number in A, I am giving it to SL. However, if F is 1, it will directly come over here and it will check whether the value of A is greater than SL or not. Now the question arises, when will F be 1? F will be 1 when there is any number which is greater than SL. So that is what we are supposed to do. We have to also, initialize the value of F to be 1 out here, because even after this, I shouldn't be coming back to this statement. I should be directly jumping to this statement. So this is how we find the second largest number. Pretty simple, I believe. Now what we are going to do is we are going to go for the last question. That is, input 10 numbers and check whether all are same or not. Now this is pretty simple. What we are going to do is we are going to input 10 numbers, and the first number that we get, we are going to store it into a variable and check. You see, the basic logic behind this is we are going to check whether all the numbers entered by the user is matching with the first number or not. If there is any number which is not matching, we'll raise a flag. That means we'll initialize a variable F with 1 to indicate that there is a number which do not match with the first number. Because if all the numbers are same, every number has to match with the first number. So how do we do that? Okay, so what we are going to do is we are going to write this. Okay, we can still reuse the same program. If I equal to 1, L equal to A. So what did I do? I stored the first number, whatever is inside A, inside the variable L. Now next time onwards, that is excluding the first number, whatever number you have entered, it should be matching with L because all the numbers are same. So in case there is no match, if it is not equal to L, then what am I going to do? I am going to put an indicator, F will be 1. And if every number matches with L, that means F will not be 1, it will continue remaining as 0. So at the end of this, you can put a check. If F is 0, that means all the numbers are same, otherwise all the numbers are not same. I believe all of you got this, and keep a note of all the techniques or tricks which you have learned today. Later on, we'll carry on modifying the same concept of whatever you have learned, and we'll continue with our programming part. Thank you.